Hey guys, Saul here, and as it's the 4th of July, a lot of the American viewers on this channel are going to be seeing a lot of fireworks tonight, and I figured that was a great opportunity to talk about fireworks. More specifically, the colors behind fireworks and why they're way more important than you might think. Of course, there's a lot of cool chemistry that goes on with making pretty colors in the sky with fireworks. But the reasons that these elements make these colors when burned is actually really cool chemistry, and it's super important to the field of analytical chemistry. So today I want to explain a bit about why fireworks make the colors and why those specific elements will make different colors in the sky and how that's used in analytical chemistry. With that, let's hop right into it. Now, a lot of you may know that fireworks get their color simply by putting small amounts of chemical compounds containing certain elements mixed in with the explosives of the fireworks. So when they burn, these elements will give off certain lights. And different elements all will give off unique colors. You have barium giving off green, strontium giving off red, sodium giving off yellow, and you have stuff like titanium and magnesium giving off the silvery white you see in fireworks. Now, these elements can actually be mixed together within the fireworks too to create color combinations. Like if you mix copper and strontium, you'll get a lavender color, even if individually strontium creates red and copper creates blue. You can put iron filings in there to get the sparkly gold color in the fireworks, and there's just a lot of cool color combinations that go along in the pyrotechnics of fireworks. Now, you may be wondering how this is kind of relevant to the broader field of chemistry past just putting fireworks in the sky. Well, since each of these elements give off a unique color, you can actually use this for analytical purposes. If you don't know what sort of elements are in a compound, you can do a controlled burn on this compound, and it'll give off certain colors, and you can use that with a high fidelity sensor to actually detect what sort of chemical makeup is in the unknown compound you're burning. This is actually a super important tool in the field of analytical chemistry called atomic emission spectroscopy. This is just like how the fireworks work, where you're burning a certain element to get a certain color, but it's done with a very precise machine and a detector to get the exact wavelength of light coming off. So how does this work? How come each one of these elements, when they burn, gives off a certain color? Well, that's actually really cool chemistry, and it goes down to the atomic scale. So as we know, each element has a unique molecular orbital and unique electronics to it. And in the orbitals of these elements, you have different energy levels. So you can have electrons sitting at lower energy levels and electrons sitting at higher energy levels. Well, what happens when you heat up an element is you're going to have changes in the energy levels and the electronics of each of these atoms. And what happens if you get an electron in a higher energy level orbital falling down to a lower energy level orbital? Well, the energy has to go somewhere, and it gets shot off as quantum energy or light. So you get a certain wavelength of energy shooting off as an electron falls down. So what this means is your atom is emitting light as you heat it up. And why this is important is every single atom has a unique orbital and electronics to it, which means all these electrons are in different places unique to the atom. And so for per atom, what happens is an electron is going to fall a certain amount, and that's going to be a different amount per atom. So on one atom it might fall this much, but on another atom it might only fall this much. And that's going to dictate how much energy is going to be shot off, and energy in light is a form from wavelength. So what happens is you have a different wavelength getting shot off from the atom, and that's going to create a different emission spectrum, or a different color of light coming off the atom, which is why different elements, when heated up in the form of fireworks or atomic emission spectroscopy, are going to give off different light signatures and burn as different colors. And this is really important because you can map out that exact emission spectra in atomic emission spectroscopy to look at what the exact thing in your unknown compound is, And in fireworks, when you burn that, you're going to get cool colors in the sky. I hope you learned something from the video. Maybe you can tell this to your friends if they're ever wondering why different elements in the fireworks give off different colors. And I'll see you guys next time.